The volume of solid revolution. In this section, we will to start looking at the volume of solid revolutions. And we should to define just what a solid revolution is. To get a solid revolution, we start to add with a function and y is equal to f of x on the interval a and b. So in the problem we have the function is y is equal e to the x and the intervals are 1 and 8.
Problem number 8. Calculate the volume of the solid obtained when the region under the curve y equal to e to the x over the interval 1, 8 is revolved about the y-axis. So the function to the y e to the x is like this, and the intervals are 1 and 8, so 1 and 8. So because we graph in y-axis, the reflection is like this. If we do in x-axis, we will be like this. So the curve will be like this, and we have like a ball, and we need to know the volume. So we integrate in y-axis because the problem.
This is our original formula, but is in the x-axis and we need it in the y-axis. So we must solve for x since what we're looking for is in the x-axis. Here is the procedure of how we solve it, and we got to the conclusion that x equals to ln of y. How to get a and b of the values to substitute in this formula. This is a, this is b. Then the problem gave us 1 and 8, so we simply substitute the values in the original formula, which gave us e at 1 and e at 8. Then we substitute in the formula to get the volume, and it says volume equals to the integral of e to the 1 to e to the 8 of p times ln of y squared. Now we have to antiderivative the formula, which I said before, using the by parts method, which is u times v minus the integral of v times du, when u equals to ln squared of y, and du equals to 2 times ln of y over y times dy, and dv equals to d of y, and v equals y. Then it gave us all this procedure, which gave us to the final formula, and then we substitute with the values we got, which were 8 and 1, and well, the result is p times 42.2025 minus 2, and the volume then is 126.2995. We use volumes with the shell method to get the volume for the function y equals e to the x. This is used in so many things, but most of all to get the volume of a solid, like it may be a sphere or a cylinder or anything that you could imagine, but we use it to rotate it in the y-axis, which here is the y-axis, here is the x-axis, so here is our object and it is rotating like this. So we find the volume of it with the applications and the methods we did see just before. Thank you very much. I hope you liked the video, I hope you enjoy our explanation, and I hope we had 100.